So what is a subnet mask? A subnet mask is like a filter that tells computers which part of an IP address is the network and which part is the host device. Think of an IP address like a street address. The subnet mask helps you figure out which street, right, which network it's in, and which house number on that street it is. Okay? So a subnet mask is a 32-bit number, so 4 octets 32-bit number, just like an IP address. And we have the example here, 255.255.255.0. Its job is to mask the IP address and help devices figure out which part is the network ID and which part is the host ID, right? So if we look at this example, the IP here, 192.168.1.10, and the subnet mask 255.255.255.0. The 255s in the subnet mask mean, right, these first 3 octet sections mean that these are the network part. And the 0 means that this last part is for the individual host, right? So 192.168.1 is the network, and .10 is the host on that network, right? So there are a total of 33 subnet masks. These range from /0 to /32. /0 means that there's no bits reserved for the network. A /32 means that all bits are reserved from the network, so there's just one host. And subnet masks can be represented in slash notation or dotted notation, right? So slash notation, you'll see here that /24, right? That's the example. And then dotted notation, it's the same subnet mask, but it's just represented in the IP address in the 32-bit address format, right? So 255.255.255.0. And they're the same subnet mask, but they're just represented different, right? And subnetting masks are just a series of ones followed by zeros. The ones represent the network portion, the zeros represent the host portion, right? So let me go back here. So we have the subnet mask /24, right? And that's the same thing as 255.255.255.0, right? Subnet masks are just ones followed by 0, right? So 255.255.255.0, that in binary, so this is where looking at addresses binary helps, right? So 255 is just 11111.1. 255.255.255.0 is just 1111. 1111.1111.1111.0, right? So this here, this is the network portion. And this is the host portion, right? So the network portion is this, and the host portion is that, right? So for the address, the network portion is this, right? We have the same subnet mask, and this is /24, right? Which is the same thing as 255.255.255.255.0. This is the network, and this is the host, right? So this specific IP address has a network address of 192.168.1.0, and its specific address is 192.168.10, right? So remember our home network. So let's say that essentially this laptop is 192.168.1.10, right? That's the host IP. And the network IP, right, that's going to be the IP address of our network, right? And that's going to be 192.168.1.0, right, for this example, right? And this computer is connected to that, right? All right, okay, so, right, subnet masks are just ones followed by zeros, right? The ones represent the network portion, and the zeros represent the host portion. /0 to /7 subnet masks are extremely large networks, right? Millions to billions of addresses. These were mainly used in the early days of the internet, when there were class A networks and fewer devices. Nowadays, we don't assign networks that big. It would be a massive waste of IPs. We normally work within the ranges of /8 to /32, but even then, /8 is pretty huge. So why we use these specific ranges, right? /8 to /32 is to organize IP addresses, right? Remember, the purpose of subnetting is to break down large networks. So we want to break down large blocks of IP addresses into smaller chunks so networks are easier to manage and route. We want to avoid wasting IPs, right? And /18 has over 16 million IPs, right? It's great for huge networks, but it's overkill for most. /24 has 256 IPs. That's perfect for a small office. And then a /30 has 4 IPs, perfect for connecting 2 routers, right? And then, right, assigning a /8 to a small office would just waste millions of IPs. You know, that would be way too much for a small office. And third is to support more networks. Instead of giving one organization a massive range, subnetting allows the same space to be shared more efficiently between many users or departments. We also want to enable security and control. Smaller subnets allow for network segmentation, meaning that you can isolate departments, limit broadcast domains, and apply different security rules to each. So this is a subnet mask table. That's for /0 to /7. You'll be able to see the slash notation and then the dotted notation, the number of hosts, usable hosts, and the number of subnets. And then same thing for here. We'll go from /8 to /16, right? Same thing. You're able to see just the dotted notation, the number of hosts, number of usable hosts, and then number of subnets. And then lastly here, /16 to /32.